Good morning everyone. Today's topic is the problems on using the inverse Laplace transforms derivatives. We can find out the given functions inverse Laplace transforms in that we are using the derivative of the inverse Laplace transform and how we can find out the given functions inverse Laplace transform. Okay, I'm taking one problem and how we can apply the derivative of the inverse Laplace transform. Okay, the problem is find first one is L inverse of S by S square plus A square whole square. The second one is L inverse of S by S square plus 4 whole square. Okay, just you observe the given function is in which form. Here find out the L inverse of S by S square plus A square whole square. In the denominator, in general, we are using the linearity property. We know the 1 by S square plus A square formula, that is in Laplace transform and also inverse Laplace transform. And S by S square plus A square is also equal to, we know that is cos AT. If A by A square S square plus A square is, we know that is sin AT. But here in the denominator, that whole square is there. If the denominator function has whole square is nothing but simply we are using the derivative. That is nothing but here we are taking the function. We know that first thing is, we know that L inverse of 1 by S square plus A square, that is equal to 1 by A sin AT, that is the inverse Laplace transform. This is one of the property of inverse Laplace transform. Okay, here the case is inverse Laplace transform of S by S square plus A square whole square. Suppose we are taking here, let f bar of S is equal to 1 by S square plus A square, then f bar dash of S, that is the first derivative of that function, is, it is taking to the numerator, that is d by ds of S square plus A square whole inverse, that is equal to whole power n, means n into f of S whole power minus 2. Again derivative of S square plus A square is, that is 2s. S square derivative is 2s, A square derivative is 0. That is nothing but here f bar dash of S is equal to minus 2s by S square plus A square whole square. Okay, here minus 2 is taking outside, then taking both sides L inverse of, here taking both sides L inverse, then L inverse of f bar dash of S is equal to L inverse of minus 2s by S square plus A square whole square. Okay, but by using the inverse Laplace transform of derivative, what is that? That is d by, or inverse Laplace transform of f bar n of S is equal to minus 1 whole power n into p power n into f of t. Okay, that is nothing but L inverse of minus 1 whole power n t power n L inverse of f bar of S. Here this is nothing but it is equal to f of t when we are taking L inverse of f bar of S. From this, f of t is equal to L inverse of f bar of S. Here in this case, this is f of t. Directly we can substitute in that f of t. In this case, we are taking only first derivative. So we can apply the value of n is equal to 1. Then that is L inverse of f bar dash of s is equal to L inverse of minus 2s by s square plus a square whole square. Okay. Here in this case it is minus 1 whole power 1 into t power 1 into f of t is equal to this minus 2 right outside, minus 2 into L inverse of s by s square plus a square whole square. Okay. We leave the L inverse of s by s square plus a square whole square. Then this minus 2 is taking to this side. Then it becomes L inverse of s by s square plus a square whole square, that is equal to minus t by minus 2 into f of t. What is this f of t? F of t is 1 by a sin at. Minus minus get cancelled. T by 2 into 1 by a into sin at. That is nothing but, therefore, L inverse of s by s square plus a square whole square, it is equal to t by 2a sin at. It is the inverse Laplace transform of the first problem. Similarly, we can take in the place of a equal to 2, then that is t by 4 sin 2t is the second problem. Again, we can solve the second one. The second one is, we know that here we can take L inverse of only the denominator what is there without taking square. S square plus 4, this is equal to 1 by 2 into sin 2t, this is equal to f of t, it is nothing but f dash of s. Okay. Here f dash of s is equal to 1 by s square plus 4. Then derivative on both sides, taking f bar dash of s is equal to minus 1 by s square plus 4 whole square. Again s square plus 4 is, that is 2s, is equal to minus 2s by s square plus 4 whole square. Okay. By taking inverse Laplace transform on both sides, L inverse of f bar dash of s is equal to L inverse of minus 2s by s square plus 4 whole square. In the given problem, the value of L inverse of s by s square plus 4 whole square means this minus 2 right outside is minus 2 to L inverse of s by s square plus 4 whole square. By the derivative of, by the inverse Laplace transforms derivative, what we have, L inverse of f bar n of s is equal to minus 1 whole power n t power n into f of t. Here f of t is that thing, 1 by 2 into sin 2t. Just we apply here, it is in the place of L inverse of f dash of s equal to minus 1 whole power 1 into t power 1 into f of t is 1 by 2 into sin 2t. It is equal to minus 2 L inverse of s by s square plus 4 whole square. Here minus minus get cancelled. This 2 is taking to right side. Then L inverse of S by S square plus 4 whole square, it is equal to T by 2 to the 4 sine 2t. Just in the first problem, we substitute in the place of A equal to 2, we are getting the second problem solution. Okay. The main thing you have to remember, if the denominator part is in whole square form, then simply you can take what is suitable the form of 1 by s square plus a square, then you can take that value. Okay. If it is minus, you can take h, sine h 80. Okay. And derivative on both sides. If the denominator has whole square is nothing but we are applying the derivative of Laplace transform or inverse Laplace transform. If it is L, then you can take derivative of Laplace transform. If it is L inverse, then we can apply the L inverse. Both are one to another related. Okay. Thank you.